Good evening, and once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I will be explaining Pure Mathematics 1 and topic number 7, and we shall be discussing example 6 under the topic of radian measure. This is example number 6. And example number 6 reads as follows. The border of a garden pond consists of a straight edge AB of length 2.4 meters and a curved part C as shown in the diagram. We have this curve. We have first of all this straight edge, which is 2.4, and we have this curve. Let's talk about a curve that looks like that, and this is supposed to be a circle, and we have the radius of the circle 2 meters, and this is also another radius 2 meters, and this straight line is 2.4 meters. This is now the curve C. That is the curve C. The curve part is an arc of a circle. The curve C is an arc of the circle. Center O, this is center O, and radius 2 meters. Find the length of the arc length C, or rather the curve C. Fine, we are supposed to get the length from this particular point all around the circle back to point, let's call this point A, and this is point B, and this is point A, as named in the diagram. So it's difficult to get the length of the arc if we do not know the angle subtended at the center by the arc. Incidentally, at the center there is no angle at all, but we realize that we are having a triangle here which looks like this. This is a triangle that has been shown to us. This is A, O, B, and this is 2, and of course this can be 90 degrees, and this is 1.2. And the reason why I've given this question this approach is to make sure that we can be allowed to use trigonometric ratios, because when we use the SOHCAHTOA, we must have right angle triangle. And in a nutshell, if you set your calculator in radian mode, then we shall be able to get that angle, and we are going to say the sine of x is given by opposite, which is 1.2 over 2. That is the sine of x. And if you set your calculator in radian mode, you will talk about sine inverse of the answer you will get here, and then you realize that x is going to be equals to 0.6435. These are radians. And in this particular triangle, you realize there's another x there, because the opposite of this x is also 1.2, and the adjacent, the hypotenuse of the same is again 2 meters. So it's one of the same x. So we are simply saying that the angle subtended by this straight line, or this particular line at the center of the circle is 2x, which is 0.6435 times 2, of course, giving us 1.2870 radians. But interestingly, that is not the angle we are supposed to be looking for. or that is not the angle that is going to give us the arc length C. It is this particular angle. It is the angle that is at this particular point. And let's call it theta. If we call it angle theta, it's going to be given by the angle at a point, of course, in radian measure. You subtract what we have, which is going to be 2 pi minus minus 1.2870, which is going to be 4.9961 radians. Now we have the theta. This theta, the angle subtended by the arc at the center of the circle. Our work is now very easy because we only need now to get the arc length C rather is going to be r theta. And what is r? 2 times the angle subtended by the arc length at the center of the circle, 4.9961 radian. And of course, you realize that the C is 9.99 meters, of course, to 3 significant figures. 9.99 meters to 3 significant figures. Please note that we have been forced to first of all find the angles of the triangle. And of course, now we subtracted from the angle at a point in radian form 2 pi, and we got the angle subtended by the arc at the center of the circle to be 4.9 radians. And then, having found that, then the arc length remains very simple, because we just have to apply the formula that the arc length is r theta, and r is given, and now we have theta, and we found it to be 9.99 meters to 3 significant figures. So once again, visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and subscribe and share widely as we work together.